Am I working? Is this working then? Good afternoon. My name is Mindy Carlson with Minnesota LTAP. Welcome to our webinar on concrete flatwork specifications. I will be your moderator for today's webinar. Also, this webinar is ADA compliant and includes closed captioning. We will be taking questions today throughout the webinar. You should see on your media site webpage on the right-hand side, you'll see a speech bubble. And if you scroll over the top of that, it should say Ask a Question. And that's where you want to click onto, and a screen will pop up for an email, which will come directly to me. And throughout the webinar today, I will let our instructor know when there's a question, and he will take the time to answer that. So we'll do that throughout the webinar. Today we're going to be discussing the Minnesota Concrete Flatwork Specifications Guide developed by Minnesota LRRB and Minnesota LTAP. The document provides specs for local agencies and the concrete industry to follow as they move through the life of a local concrete project. A link for the document that our instructor will be referring to today is located on your media site screen on the bottom left-hand corner, and that will direct you to a PDF of the manual. We also have a link to the guide on our concrete webpage for the webinar at the Minnesota LTAP website. Today our instructor is Dan Frentress of Frentress Enterprises. Dan's consulting business specializes in concrete training and research of concrete pavements. He manages the ACI MnDOT certification program for the Aggregate and Ready Mix Association of Minnesota and provides promotional help to the ready mix industry. During his 28-year career, Dan has served as Vice President of Highways for the American Concrete Paving Association and as Executive Director of the Concrete Paving Association of Minnesota. He holds a professional engineer's license in Iowa and Minnesota. So, welcome, Dan.
Thank you, Mindy. Sound working okay? Good afternoon, everybody. We're going to talk about the new concrete flatwork specifications. The first thing to talk about there on the second slide is that this is a standalone specification. The committee was put together, and the committee first started by making it a supplemental specification with the spec book. And then the contractors got involved and said, don't tag us with the whole spec book, make it a whole standalone. So this is a standalone specification using the MnDOT system, but it's a standalone. The whole spec book is not there. If the engineer wants anything out of the DOT spec book, they have to add that as a special provision is the idea. The intent is to use the MnDOT existing forms and everything. And the idea is to build better concrete. We want better curing and better concrete in our flatwork area, curb and gutter, sidewalks, and also pavements is what it is. The mix design is a performance mix on strength, but it's based on limits. So it's part performance, part prescriptive, as you will see as we get through here. Different things to ask for at the pre-construction meeting for this. First would be the contact form to make sure that you're getting your concrete from a certified ready mix plant. Quality aggregate tests need to be turned in at that time too. And this is all that the MnDOT system, the ready mix people should have these piles approved for MnDOT work, and the paperwork needs to go with these projects led under this specification. Also, certified materials to be used on the project. We'll let the DOT certify the materials, but you need the paperwork to put into your system for the local agencies so you have that. What's different on this is there's going to be a list of certified people to run the field test, either the contractor's personnel, whether it's the flatwork contractor or the ready mix person. And for the first time, this specification asks for ACI certified finishers. There's a certification program with the American Concrete Institute that we instituted here, and we'll talk more about that later. The last note that we have here on this slide, busy slide, is that if the engineer hires a testing firm to do their quality assurance part, the intent of these specs is that the contractor personnel would do the quality control test on a regular basis during the day, and then the engineer would hire somebody to do the quality assurance part of the testing if they desire. And if they hire a testing firm to do that, the city does, then the contractor can't hire the same firm to do their half of the quality control, quality assurance. That wasn't spelled out well in the second version of these specs that were updated last July 25th, I think, 2012. We're running with version 2 here. This year, the first year on the rollout of these specs being used by people. So that was something brought out this year as we reviewed the specs. The other thing new in this is a quality control plan. There's 13 different items in the quality control plan, such as traffic control, list of certified people, things of that nature, certified ready mix plan. The 4 I picked out here to talk about would be rain protection, hot weather protection, a cold weather protection, and a curing plan. The intent is if you have a cold weather plan, instead of the engineer for the local government agency telling the contractor what to do when it gets so cold, they'd rather have the contractor take a list and say, when it gets to 36 degrees at night for the concrete, we'll do this. When it gets to 33, we'll do this. 30 degrees, this, 38, and then that plan will be approved by the engineer. So then it's easier for the engineer to come on the job site and say, okay, it was 28 degrees last night. You said in your plan you're going to give me 2 sheets of poly and monitor it. Where's the information? Where did you do that? So it's trying to make the contractors decide how to handle these problem areas like rain or hot weather, cold weather, and then institute it on their own instead of being told by inspectors. This is very much a contractor-driven specification is the intent of the idea. This is developed for less agency inspection and greater contractor responsibility, hopefully to build more durable contract, and it requires concrete, and it requires contractor certification, and then more responsibility on the contractor for daily and the pre-bid quality test results is the idea. The mix design is a performance mix. We're going to go with 4,000-pound concrete at 28 days, compressive strength. Most of the MnDOT mixes are A mixes, and they run at 3,900 PSI strength. So we made this one 4,000, so it'll be different. So you know you're into a different spec than the normal Minnesota DOT, which are anticipated strengths. Now the DOT works by controlling the ingredients that go into the mix, and so you hire inspectors to watch, make sure that's right. We're going to kind of use the same system, but it'd be the ready mix person telling the agency the mix they're going to use and the weights they're going to use, and those would show up on the certificate of compliance ticket. So it's a performance within limits. We're going to continue with the old A mix that the Minnesota DOT has used for 40, 50 years with 400 pounds of minimum cement, 530 pounds of total cementitious content, which is roughly 130 pounds of fly ash and 400 pounds of cement as a minimum. And then we controlled it by a maximum 658 pounds of total cementitious. We set the water cement ratios at a maximum of 0.42 for machine placed and 0.45 for hand placed concrete. And these follow the DOT recommendations now as well, the 4.2 and the 4.5. And that'll be calculated on the tickets, the certificate of compliance ticket that will come with every ready mix truck that the MnDOT system already has in place. So that should be used on this with these contracts. On the designing side, the idea was to have less bid items for the designers to include and not to do a complete joint layout. If a joint layout is done by designers, that's fine. Otherwise, the specifications say, the Flatwork specifications, if there is no joint layout, the contractor would provide a joint layout that would be reviewed by the engineer. So the idea is to make it simpler. So in the current MnDOT system, you would keep track of dowels separate and pay them per dowel per each. In this system, if there's a dowel design, the designer would show it in a cross-section, show what he wants, and then those dowels would be included in the bid price. And the designer then tells them how long the project is, and they want a maximum 15-foot joints or 12-foot joints, whatever it is, so the contractor can bid in the number of sawing and sealing and dowel bars he's got to buy. Steel is generally been incidental in the MnDOT system for tie bar steel. In this case, it'll continue that way. And so the steel here in this picture, the tie bars down the center line there, would be incidental in the MnDOT system to the price per square yard of concrete, and then the dowels would be separate. In this new specification, all that steel is incidental. It's included in the price bid. We have an item called concrete pavement. So if it's a 7-inch concrete pavement by the cross-section, has dowels in it, that would be incidental. If you have the same project, you might have a 6-inch concrete pavement, and you might not have dowels in that. That cross-section would show and it would not have that. Some of the things the designers got to remember is where we put reinforcing around manholes. And I apologize for the slide. They're as best I could find. But when we use telescoping manholes that we like to use on our city streets, concrete, then we need steel around those manholes. That steel would be incidental to the price bid for the concrete pavement as long as the designer drew a typical section and told the contractor to include this. Another place we use it is some temperature steel, and we get long, thin sections of concrete on a radius like this. The red hash lines are meant to be kind of temperature steel we'd put in there for if that section cracks, the steel would hold it. In the past, the inspectors and engineers could add the steel in the projects, and those pounds of steel were paid to the contractor. In this specification, if the designer wants that done, they need to show a typical like this and say, I want steel there when it gets to such and such a size, which is usually under 3 foot. We teach the 3-foot rule. The other place we use steel is at the end of a joint on a sidewalk like this. We call them reentrant corners. Just the joint design the contractor did drove it to this where there's a chance of a random crack coming out of that joint, just a little upper left of the arrow I have there. And then we put 2 rebars there, usually number 13 metric bars. That's the old half-inch English standard. And then steel is passive until the crack happens. Then it becomes active, the steel does, and it'll hold that crack from propagating too far, opening it up and giving a problem. But these used to be incidental, and the inspectors would pay for those pounds of steel and keep track of it on every job. Now they need to be incidental to the price bid for like a sidewalk pavement. So that's something a little different for the designers to think about when they're putting plans together. Here are the structures. The curb and gutter on the left is an intake. Some designers that reviewed this, some engineers, told me they don't like to pay for that metal intake there because there's no concrete involved. That would be a special provision for them using these specifications. And so we would include that lineal feet in these specs, such as the manhole there in the middle, and that's a telescoping manhole in the middle of that street there. And that area of the manhole is also included in the square yards of concrete pavement. The DOT pays it that way today, so that's not a change. But any of this extra steel would be paid for in the price bid for lineal foot, curb, and gutter. All the intakes that are drawn on the plans that are necessary would be included in that price. So the specification is set up in 5 main parts. There's a general part that gives definitions, basically. The engineer or contracting authority's representative. We get into city councils and mayors and things of that nature, some engineers, some consulting firms they hire, and then the contractor. Those are the 2 basic. Contractors are going to be broken down into like the Flatwork contractor and then the ready-mix supplier. Products, execution. We have a specification in here for concrete strength by the maturity system we'll explain here in a little bit. And then a pre-pour meeting. We put that in as a separate, one of our main parts, as an example of a pre-pour meeting that should be held when you have 500 cubic yards or more in a single pour or in a single day. So those are the 5 main parts. The first part there, general under 1, and you don't have to follow through your specification. I'll send you to a page here in a minute, but these are the, let's see, 2, 4, 6, 8 different bid items that we see in this spec. And the ones that we put in red here are ones that are kind of a choice whether or not to have those bid items. First part we see you have concrete pavement. If you have a 5-inch concrete pavement and a 6-inch and a 7-inch concrete pavement on the same project, you'd have 3 different bid items, 5, 6, and 7. Inside of those, then you would have your steel, whatever steel you need. Curb and gutter would be by the lineal foot, and then your intakes would be included in that price. And then any steel in the curb and gutter. Driveway entrances, the same thing. You'd have probably 6-inch and 8-inch driveway entrances, so you'd have 2 different bid items. The DOT generally puts in 8-inch driveways for commercial driveways and 6-inch for residentials. And then sidewalk and concrete, medium concrete for your sidewalk or your medium concrete. So, but then if they go to concrete field testing, the engineers wanted the ability to take the construction dollar budget and have the contractor hire a testing firm to do the quality assurance side. So when the contractor hires that firm to do that side, then the contractor can't take and hire the same firm to do his side of the testing. It should be separated out. It seems common sense. We don't have that written in the specs, but that would be the way properly to, if you want to throw yourself into a judge or a jury situation someday, you'd want those 2 parties separated. The letter F there is a concrete pavement smoothness. The smoothness on all these in this specification is 1/4 inch and 10 feet, unless the agency wants to have concrete pavement smoothness checked. And then we'll do that under the new International Roughness Index, and it's called the Area Localized Roughness. We'll cover that later. But that'd be a separate bid item, and only on streets. And then the contractor knows he's under a tighter ride specification than the 1/4 inch and 10 feet. Maturity testing for compressive strength. This is a way to determine your concrete strength every hour, every 6 hours, every 8 hours, whenever you want, to open up driveways for McDonald's or driveways for residents quickly, or intersections that you get into. So again, this would be a separate bid item. Then the contractor would probably hire a testing firm to build the maturity curve. It's a 2-step process, and then also to do the work in the field. The last one, H there, is an enhanced coarse aggregate quality. And we basically took the 2 DOT specifications. They have aggregates for general concrete use, and then they have aggregates for bridge construction. And that's what the enhanced coarse aggregate quality is, or for the aggregates for the bridge construction in this state. The consultant called me up and said he'd like to use granite aggregate in some of his sidewalks. The worst place to have our pop-outs we get from the glacial aggregates is in the sidewalks and by church and things of that nature, where the women in their high heels might catch them and twist an ankle or something. Roads and things can live with more pop-outs because you get cars and vehicles traveling across it. So I told that engineer if you wanted granite, then you just specify it and call it a special provision, and they'd include it in the price. But we don't have granite available through the whole state. These are statewide specifications. So there will be special provisions to the specification. And I want to say we're going to try to keep track of the special provisions as the spec is rolled out here. It comes right now as a technical memorandum in the state aid office. And as these special provisions, we're going to work with Ron Dahlquist, the associations, Matt Zeller with the Paving Association, heavily involved in this, Maria Maston with the Concrete Office, heavily involved, and Fred Corrigan with the Aggregate Ready Mix Association. We're all heavily involved. And we're all, four of us will try to watch and get the copy of the specifications that are used to Ron Dahlquist of the State Aid Office. And there we'll look and see what special provisions are used. And if everybody's putting the same special provision in, then next year we'd update the specs with that as a change to the specification. We'll let the engineers and contractors find the holes and problems with this spec. There always is when you roll something out new, until you actually use it in the field and think, oh, we forgot to put this in here. We think we have everything included by those people I mentioned that gave us a lot of help. But anything like that would be special provisions. So in red would be separate bid items. The testing rates for this is going to be by type of work. We have two tables, Table 5 and Table 6. Okay? And Table 5 is the option of no engineer testing. It can be just tested by the contractor and the reports turned in. Table 6 is much more testing by the engineer, a regular quality control, quality assurance system. And those tables, if you wanted to go to any page, this is on page 26 if you're following along. And I'll bring it up later as well. But this is the Table 5, and this is only available for curb and gutter, sidewalk work, and median work, not for concrete pavements for city streets. And if you look down here, contracting authority's representative, the testing is at their discretion if they want. You take it down to the cylinders, the compressive strength. The cylinders would be made once per day by the contractor or ready-mix representative. Then they would be given to the contracting authority's representative after 24 hours. They'd move them to a moist cure room, a lab they would hire, and have the testing done independently of the contractors doing the work. So that's the only thing that the engineer, but it's their choice if they want to do more testing. And then the rates here are different than the DOT. We went to 200 cubic yards for the testing of air and slump instead of 100 cubic yards. And then page 27 is Table 6. And here we have the contracting authority's representative testing rate, which is at every 400 cubic yards and 200 cubic yards by the contractor. The contractor testing rate in these two tables is the same, whether it's Table 5 or Table 6. If he sees concrete testing as a bid item, then he's basically hiring somebody to do that Table 6, the second half there, the quality assurance part. So that's how he tracks it along. We'll talk a little bit more about this later when we get farther down in the book as I built the slideshow. But wanted to point that out as something to follow along, and you may have questions about that. If you look at those pages, Mindy will take the questions. We'll try to answer them as we go along here. Part 2 in this specification is the products. I mean the cement and supplementary cementitious material, basically the fly ash or ground granulated blast furnace slag cement is what's used there. Fine aggregate, coarse aggregate for concrete, the concrete mixes, the products that go in there, basically your cement, water, their fine aggregate, the admixtures, joint sealers. We're going to use the MnDOT system, which tests these products on a regular basis. It's just the paperwork you need to get into your files to be available. And while I say that too, we asked Julie Skolman last week, getting ready for this webinar, and she said for the 2013 construction season, these specifications will not be available for any local federal aid projects or projects on any trunk highway right-of-way. These only be for local government cities to use on their local government tax dollars. There's meetings, there's discussions about opening this specification up to be used with the federal money, and that gets Federal Highway Administration approval. So they're working with those folks. And we'll see how the rollout is this year and how these specs are used and how the reports come in. That'll help all of this. But the idea is to use the DOT system or an ASTM-approved system. Aggregate people build aggregate piles for ASTM, I'm sorry, that's American Society of Testing Materials specifications, as well as piles for the local Minnesota DOT specifications. But a lot of the private work in the Twin Cities, our new Viking Stadium probably, the library, things of that nature, the light rail, they use some ASTM specification piles. So we opened the specification up that they could use those piles in this work as long as the pounds and the gradations and everything are in tolerance, or they can use the DOT-approved piles. So that should help the ready-mix people keep prices in line. If they've got a pile built in aggregate there, they may put it into a curb and gutter and sidewalk instead of having another pile brought in. So the idea is, again, to use the DOT system that's in place. Again, this specification is part prescriptive, part performance, and part prescriptive. It's a 4,000-pound PSI, pounds per square inch concrete at 28 days. Traffic is allowed anytime you hit 3,000-pound PSI concrete. And with the water cement ratio is set at maximums of 4:2, for paving work and 4.5 for hand work. Consultants have asked me why we didn't put a penalty in here. We believe the old MnDOT mix of the A mixes were really close to 4,500, 5,000 pound mixes, and that's our minimum in this spec. We feel that if you fall below the 4,000 pound at 28 days or earlier, you know, you'd have real problems, more problems than just the mix. You're talking more removal. So we left a penalty out of this. We didn't feel necessary if it's 39 or 3,800, there's a 500 pounds per square inch area there that they can fall into to averaging the cylinders. So first thing to do would be take some cores out of the work and see what the strength actually is in the product, and then work on discussions after that. But we don't believe, everybody on the committee believes this mix, for these minimums, if everything's done correctly, should be easily to hit 4,000 pounds per square inch concrete. So we'll see how that works out. One of the things we'll learn as we go through it. The strength will be done with the cylinders generally. What we have to watch for is the 4-inch by 8-inch tall cylinders are maxed out at an aggregate size of 1 1/4 inches. It's basically the rule of 3. 3 times your aggregate size sets the diameter of your cylinder. So 1 1/4 inches times 3 is 3 3/4 inches. So then we'd have our 4-inch by 8-inch cylinder. Some of the paving mixes we might get into 1.5 inches top size rock, and then we have to go to 6-inch by 12-inch cylinders for the compressive strength. And here it is too, the compressive strength. The ready-mix people can give a MnDOT mix they've used for years, or they can give their own mix, and according to ACI 301, it's by the field experience method or by lab trial batch method. The ready-mix people do this in the private work for buildings and different specifications they build, so they have those mixes available. So it's kind of open up and let them use their own mix within those cementitious requirements, and they don't have to use MnDOT mixes. So the mix then belongs to the ready-mix and the contractor. So they can fix the yield if they want, and the air content, things of this nature. They can work with the mix to get what the contractor needs on a daily basis, is the idea. So these would be the minimum and maximum cements and fly ashes in the mix. And I'm not going to go through all these. It's maxed out again at 658 is the maximum we want in this specification. Historically, we get our strength in 7 days with most concrete mixes. And early strength mixes is what we call these, usually in 3 days, but you can use a maturity system. We purposely called these early strength mixes. The DOT calls theirs high strength mixes, high early strength mixes. So try to get the terminology a little bit different. Lower water cement ratios obviously help this strength. Early strength mixes, again, will be designed by the ready-mix people. So they can use some fly ash in there and some accelerators. In the past, they'd have to get permission from the concrete office to use the accelerators. And the maturity system we'll describe here is a good way to monitor the concrete strength as you go through the project. The slump specification in this spec is a maximum 5 inches. No more slump ranges in different mixes. Slump only needs to be run on hand-placed concrete, machine-placed concrete, no slump test required. But when you make cylinders, you need a slump, air, and temperature test when you do strength specimens to match up. So again, there's no slump penalties in this spec, just a maximum 5-inch slump is what we set it at. They use admixtures and water reducers, superplasticizers. That's between the contractor and the ready-mix supplier. So that's where the mix is really their mix. We want the certificate of compliance reports that the MnDOT system developed and the ready-mix people have invested in to be used on this project. We use the same system MnDOT does, and one of these come with every truck that's delivered. When there's testing done on that load of concrete, the testing person, whether it's the ready-mix personnel or the contractor personnel, goes, runs the air and slump test, and fills it out on that certificate of compliance ticket. They sign it as the person that done the test. Then the person can check to make they're carrying a current certification card. And then at the end of the week, they take those reports and turn them over to the contracting authority, much the same way the DOT inspectors do. So somebody at the ready-mix plant or the contractor the next Monday would sit down and take the reports that they do testing on, the first truck of a pour every 200 cubic yards and maybe every 400 cubic yards by the agency person, take those reports, put them on the concrete weekly report, and send it to the agency that you're working for, the city of New Hope, city of Andover, whichever it is, Dakota County or Anoka County. They put it and have in their files for that audit check later by the feds or somebody that might need that. So it's the same system. We're just taking the work and turning it over to the contractor personnel instead of hiring inspectors to come and do this work. So the admixtures that are allowed in this specification are basically all the admixtures. Type A, water reducers, mid-range. Type B, retarding hydration. And accelerating mixtures. Type C is what MnDOT does not allow. MnDOT allows the Type A, Type B, Type D, and Type S, and they're what we call cookbook recipe mixes, where the concrete office controls the mix by how many pounds of cement, how many pounds of fly ash, how many pounds of fine aggregate, how many pounds of coarse aggregate, and setting the air content at 6.5%, which we kept in this. The air in this is 6.5%, plus or minus 1.5. We tried to follow the DOT specifications so you wouldn't have to relearn things when you get on one of these projects. but we tried to open it up so you have more choice of how to design it and do the mix, like the accelerators here. The ready mix supplier can use accelerators, and that's how they'll get their early strength concrete mixes to get the McDonald's driveway open for tomorrow. Execution is part 3 of the specification, and here is where we require the contractor to have 2 people with a current American Concrete Institute Flatwork technician certification. And the idea is to have at least one of these people on the job site during every concrete pour. The contractors that have been calling up and holding classes, they've been trying to get all their people certified. So they have them there and they're available. They don't have to worry about having this person on this job and that job. So that's their choice. But this is the first time we know in Minnesota that we've required certification by the Flatwork contractor, the placing contractor for concrete. So that's new in this spec. Pre-pour meetings, we ask for pre-pour meetings for 500 cubic yards of concrete or larger in one pour or in one day. And there's an example in the specification. Basically, is the project people, the grading done, what's the concrete schedule, the mixes, what you're going to use, who's doing the concrete testing today, how often are you going to do it, and then concrete placement, and then a curing plan is what we ask for, that the contractor has his information that if they're calling for rain, he's got his plastic there to get ready for a rain, make sure those things are on site at this pre-pour meeting. And who's doing the testing? Is the ready-mix driver going to do the testing, or is the contractor personnel going to do it? So that's kind of the pre-pour meeting. These meetings have been happening, matter-of-factly, because the contractor calls the ready-mix person up the night before. It's, okay, I need this, how much? Just want to make it a little formal here in this idea. But again, on projects that pour 500 cubic yards or more. The ready-mix plant can be either Minnesota DOT certified or American Concrete Institute certified. The difference is the American Concrete Institute certifies the actual trucks that are used to carry the concrete. The ready-mix, the Minnesota DOT just certifies the ready-mix plant. The ACI also certifies the ready-mix plant. Almost everybody in the state that wants to serve DOT concrete gets their plant certified, either by the concrete office or by a technician from one of the DOT offices. So we don't want to change that system. But if there's a plant that was ACI certified, we wanted to make that available. It's actually another level up on the certification by checking the trucks out as well. So either one will work. We expect most people to have the Minnesota DOT certification. That has to be done once every year, and then that paperwork again goes with the project. The air entrainment, we're going to use the same 90-minute delivery that the DOT is using now. The specification will be 6.5% target with a 1.5% range of 5 to 8%. We're going to follow the new DOT that no water is added after 60 minutes. That's written in the specifications. If they deliver it in ready-mix trucks to a paving machine, they'd have to deliver that concrete in 45 minutes. Basically all the same specs the DOT is using, and that's for Type 3. There's also Type 1 concrete by the DOT that has no air. That's a 90-minute delivery as well with the same 60-minute time for adding water to the truck. So all those things follow the same DOT system as the intent. These are some of the forms that we have to use. The contact report, the 2163, is the certified ready-mix plant report. The weekly certified ready-mix report there is what's done from the plant, and there's also a certified concrete report from the field, where the field tester put in. So that's done once a week and sent in as well. Again, using the system the DOT has available. These forms are available on the DOT website. You can download them. A lot of them come as a Word and Excel spreadsheets that you can type in the answers and save it to a file and get it to the contracting authority again. So we're trying to use everything the DOT has there and not reinvent the wheel. They've done so well to make everybody follow is the intent. Concrete placement equipment, we allowed slip form paving, fixed form construction, and we have a little bit on the curing equipment in the specification, which is a little bit different in there. Slip form placement is just slip form placement of concrete. This picture here shows actually a conveyor using to bring the concrete there and the dowel baskets that have to be pulled over and placed there. This is actually down in Olmsted County, I think, one of their county projects down there, or the city of Rochester. The texturing for pavements, we decided to stay with what the DOT has been successful with, which is called astroturf drag or a longitudinal broom finish. We lowered the requirement down to 0.8 of a millimeter depth of texture. The test is called a sand patch test. On the DOT interstate highways, they use 1 millimeter depth of texture, and we lightened it up here on city streets. Okay, and this test is not a specification that the test has to be done on a regular basis. It's only done when the texture is in question. The intent is to make sure there's some texture there, but not too much. we have slower speeds here, and the whole idea of this spec is to change from what's happened in Minnesota. These cities have really developed their own specifications that have built a lot of concrete. City of Owatonna, City of Austin, Minnesota, City of Rochester, Minnesota, City of Minneapolis, City of St. Paul. When they get a concrete project, they take the DOT specifications, which are designed to build an interstate highway carrying traffic at 70 miles an hour with a depth of texture of 1 millimeter depth of texture. When you get into city streets, you don't need that kind of depth of texture to stop a car going 30, 40 miles an hour. So we lightened it up a little bit. So we didn't see a need to have it tested. On the interstate highways, it's tested every day by the contractors. And if it's not deep enough, they have to come back and diamond grind it. The same penalties would apply here if need be. And again, this is an area we didn't set up testing requirements for, but it's there, the spec is there, and the engineer can enforce it if he needs to if something happens. So that's the idea. This test is only done when the texture is in question. And again, the whole idea of the specs is to build a specification that allows city streets and local government agencies to build concrete city streets that are efficient, functional, and affordable, instead of taking interstate highway type testing rates and putting them down into a city street system. So that's kind of the genesis behind the specification. The astroturf drag, this is why the concrete folks do it on the main line. They actually use class 5 or dirt there or rebars until they get deep enough, and then they take it off the next day, or they use brooms. They can do that. Either way, it's tested behind. In this case, it would be enough texture just with the astroturf drag. But we were pointing out by the contractors as we were developing the spec that on curb and gutter and sidewalks, you have to use a broom, a finished broom, like they do in their normal flat work. So the astroturf does not apply here. The 0.8 millimeter does not apply here. This is a very light broom finish that we want in all our curb and gutter and sidewalks. And including any slip-form curb and gutter and sidewalks, the same thing. It would be the light broom texture. No astroturf necessary there. Fixed form construction is when we pave these city streets with this is a Bidwell, basically a bridge deck paving machine that's used to pave streets. I live in Park Rapids, Minnesota. There's a little downtown Park Rapids, a 6-inch concrete street that went to alternate bids. And this is what's happened. This alternate bid came within $30,000. That the concrete was $30,000 more. The city council voted to go to concrete and make it it's a tourist town, Park Rapids, Minnesota. And they did a lot of stamped color here in this town to dress it up and make it more of a tourist destination. And when it's done, the testing costs, they basically compare it against asphalt. And they've built asphalt on these city streets under the local government money without all the testing done with asphalt that's done on the interstate highways. And so here we're trying to copy that system. But this one, they did the regular testing rate of every 100 cubic yards and everything that's done on a state highway. And the testing costs got the city council a little upset. We had to pay all this extra money. We thought concrete was this much more, and then it was this much more. So this way, most of these costs would be included in the bid. So when they go to alternate bids, the testing costs will be there, and the cities will know what it is. They won't get surprised at the end of the project from their local engineer. So that's, again, kind of the genesis and what started the specification. And again, we're going to learn. We'll find the holes and things like that. Mistakes we made and things we'll have to work on. The curing of all concrete will be done at the same rate, the DOT, 150 square feet per gallon. We're going to go to the new, it's called alpha methyl styrene cure. Sorry about that. Alpha, A-L-P-H-A, methyl styrene. That's what the AMS stands for. It's 3754 by the DOT specification. It's a very good cure. It's an expensive curing compound. And then we're going to use the MnDOT system of the cure should be placed within 30 minutes, or there's an option of doing a monetary deduction of $50 per cubic yard of concrete placed. If they give you an invoice and it's cheaper than the $50 we figure is half the price of the concrete. So if they're selling concrete for $80, you can get by with a $40 penalty. Most ready mix is $50 or $110 or $120 prices. So we think that we're going to follow the DOT system and try to put a penalty out if the cure is not placed on soon enough. It will require an airless spray machine for the curing compound. It's basically a recirculating cure cart. This cure has so many solids in it that the solids will not, it'll plug up your nozzles and things if you try to use a Hudson sprayer. It's the same, the DOT is going to this cure. They went to it last year on all their work. They've been using it in the pavements for about 15, 17 years with success there. So we're going to bring it over into the Flatwork, curb and gutter, sidewalks, and things of that nature. But it will take a recirculating cure cart. And what we're trying to eliminate is the poor curing like this, where the cure is not covered well. You can see the footprints there from the Bobcat that drove up there, or some kind of rubber-tired machine, and wipe the cure off. So the DOT system you cure it until it's white like a sheet of blank typing paper. And that's as good a spec as any in the field to use. We're following that lead in this specification. Again, this cure, the Hudson sprayers won't be allowed. They won't use them very often. They'll get plugged up. There's so many solids here. But you can use the AMS 3754 or linseed oil of 3755, not water-based. If you get into the colored architectural concrete, then you'd use a special cure, the fugitive dye that the DOT has. So you don't ruin your color is the idea. So curing's a little different here. Again, the testing of the air and the slump in the concrete will be done by contractor personnel, which used to be done by inspectors. And Table 5, if you have that open on your page 26, the idea is the contractor tests the air and slump every 200 cubic yards. They do the first truck of the pour, make sure that's correct before it goes in, then every 200 cubic yards. The agency decides if they want to test or not. Cylinders will be made by the contractor, and the agency will test the cylinders. So this is that chart on page 26. And you look up there, and I mean, things to be done before the bid, the gradation should be in the moisture content. Obviously, every day you do that, and aggregate quality. And then, of course, aggregate testing, the minus 200. But then the tests on the job site start there with the air content, slump, temperature, compressive strength. And again, the slump is not required if it's for slip form placement. Handwork, you do the slump test, same as the DOT. But when you come down to make the cylinder, then we need to have a slump test and an air test and the temperature of the concrete to match up with the cylinder. Because if there's a low-strength cylinder, it's the first thing the testing agency asks is, what was the air content of that concrete? So you want the same concrete that the cylinder's made out of. What was the slump, and what was the temperature of the concrete at the time of placement? So those have to be done there. So you still have to carry your slump cones. And then the contracting authority's representative tests are almost all at their discretion until you get down to the bottom. The intent was, I mean, some of the consultants tell me they've been building some old TV towers, I should say TV towers, cell phone towers around the state. And then they got to send a technician out to meet the ready-mix truck, you know, and run their one test, and then done for 100 yards, a 60-yard tower, just once every 100 yards. In this case now, the engineer could use this specification and require the contractor to bring somebody certified to run the test, instead of running this technician 2 hours out in outstate Minnesota to go to a spot and then come back. So that's one of the places we think this spec can be used. Again, the MnDOT couldn't change their system because of the interstate type work they're working with. Table 6 is agency minimal testing rates for concrete pavement. Anytime the engineer wants to do it for curb and gutter sidewalk, he can use this table as well. But this is the minimum table for concrete pavement. Contractor tests the first load and every air and slump every 200 cubic yards. The agency will test every 400 cubic yards. In this specification, cylinders will be made by both the contractor and the agency personnel. But testing the cylinders will be done by the agency personnel, except for, and that's a standard test, the tested. But if they want to build control cylinders to determine when to open the driveway, those will be done by the contractor personnel and kept by them and then tested at their choice when they want to get traffic on an intersection early or through a McDonald's driveway or something of that nature. Engineers can also require that in the plans. They can say we want this under early strength concrete, this driveway, and it will be tested and dictate cylinders be made. And that's their choice as well when they have, because they're dealing with the public. They're making the deal to rebuild the road and keep the public in and out and keep businesses open. So there's some deals there made that the contractor needs to know about, and that's part of that pre-construction meeting or in the bid, hopefully, in the plans. So this is table 6. If you look down here in the contracting authority's representative again, it's down there on your air and slump temperature every 400 cubic yards. First truck of every pour, and then every 400. Well, I shouldn't say that. This is just every 400 cubic yards. The first truck is done by the contractor personnel, not by the contracting authority's representative. So they can get up, started in the morning, and the representative come out there at 400 yards and take their test and match up with a quality control. The quality control person should test the first load every day of every pour. So that's the rates are larger. Again, 200 yards instead of 100 on the DOT, and then 400 by the QA part of this specification. And the last one down here is concrete pavement thickness on this page, and I'll talk about the probing here in a second. The idea is to use probing instead of using cylinders or cores, I guess, out of the pavement. The DOT's backed off on the number of cylinders they're doing, and this one we're not doing any, but at least observation or coring at their discretion. If the engineer thinks the pavement is being built thin, it's a 5-inch pavement, he can core it at his discretion. The penalties are in here for that. If you core and it's thin, it's not thick enough. It's the same penalties in the DOT book, which are pretty steep, so it gets their attention. The surface smoothness is, again, it's a 1/4 of an inch and 10 feet. If you require this concrete paving, by a RIDE specification, it's done as called ALR, which is area of localized roughness, and it's shown as a separate bid item. The areas of localized roughness uses it's IRI, that's the International Roughness Index, and we require a MnDOT certified profiler and a certified operator. The paving contractors, both asphalt and concrete in this state, have these machines and those people, as well as some of the testing labs will get into this work as well. So this is a look at the machine that you would use. The machine has to be certified, and also the operator. It's usually certified once a year in the first 2 weeks in May. And so we'll use that, and we'll use the DOT system in certifying it again. The thickness, again, coring's not required in this specification, but we use contractor quality control probing. And so they probe it. The results are turned over to the contracting authority on a weekly basis. In this spec, we ask them to do it every so often, so they have to do that. Penalties are assessed according to the same penalties in the DOT system. Most concrete folks try to build their concrete pavement a little thick. It's cheaper to put a quarter or eighth of an inch down or so than to have short cores with the penalties. So no coring required here to check thickness, just probing. The maturity system is a separate bid item. It can be used with any concrete mix. Okay? And it must be recalibrated when there's a change in the cementitious product. If you're building with a Lehigh cement, you change and start building with a whole cement, you have to rebuild your curve, is the way everybody in the country uses this today. The concrete office is having some research done at Mankato to find if this is true or not. They're purposely building cylinders with different cement products and seeing if it actually makes a change in the maturity curve. We believe this can provide the greatest benefit with the early strength mixes, is where we think. And basically the way this system works, and you have to pay for this, so it's a separate bid item. You make 12 cylinders. In the last cylinder, you can see the person there with some wires coming out of it. You put a probe in there. And then when you break a cylinder, you read that probe. And it really takes 3 cylinders to get a strength. And so as you break cylinders here at specific times, and we set it up in the spec, at 1 day, 2 days, 3 days, 4 days, we break the cylinders. And as we break the cylinders, we get day 1 average. And the bottom chart there, your x-axis, if you will, is the maturity. That's the temperature of your concrete and the humidity in there. And on the left is your compressive strength, the y-axis going up. And so you build this curve that is to your mix. When you change cementitious, you got to build a new curve. And so then what you do in the field is you embed these sensors. These sensors come out. There are wireless sensors. They're available also. But these are wire ones. You put them in the concrete, and then you come back with your meter and you read it. And you take the reading off your actual concrete, and sometimes it'll be 3 days you'll hit your 3,000 pound compressive strength. Sometimes it'll take 5 days. Depends on the weather. Colder weather is going to take longer. And then you come back to your chart. You read your chart like that when there's around 6,500, what is called degree Fahrenheit hours is what it is. And you come up to your curve and come over there to the side, and it's 3,675 pounds per square inch concrete. You can come up and read this thing every 5 minutes, every hour, every 2 hours, every 8 hours, every day, whatever you want. And so you don't have to break cylinders, because eventually you run out of control cylinders if you're trying to chase an early strength for getting a driveway open. So this is a very benefit for opening up driveways and intersections when you want to carry traffic through there. Again, it's a separate bid item, 2-part bid item. One is to build this curve. The other is to put the pucks in the field. The washout guidance, we're going to follow the guidance from the February of 2009 by the Minnesota Pollution Control Agency. Either a washout pit or the ready-mix trucks have a pump to put it back in the truck to take care of it. We'll follow the washout guidance on those rules. This is kind of what we're looking for. This is a picture of Highway 96 in Ramsey County with the colored intersection there, the colored crosswalk. That's what we're going to get into a lot with these specifications. Regular concrete and then the colored and things of this nature. So, in summary, these specifications are available at the state aid website of the Minnesota DOT as a technical memorandum. They can be used as a separate specification from the MnDOT specs. We want to make sure we understand that. These are standalone specifications. If there's anything out of the DOT book, like dirt work or anything like that, you have to add that as a special provision here. We're encouraging engineers to use the entire specification on projects, sidewalk, curb, and gutter, to promote uniformity around the state. And you must add any other specifications you need for a project as a supplemental to these specifications. Is the key to this. And again, this is a new specification. We know there's mistakes and things that are missing here. We expect to try to update it over the next 2 to 5 years and get a completed one here and get the questions answered. So if you have any questions, my information is available at the ReadyMix website as well as LTAP. Send me an email or give me a call. Glad to answer and help any questions. And I appreciate everybody that called before this webinar that helped me out with some questions. With that, that's all I have. If there's any questions that Mindy has, we'd sure glad to handle them. Nobody... That's fine. That's kind of where we wanted to be, around 45 minutes. So I'll turn it back to Wendy if you wanted to close it out. Or
just like to say thank you for watching today. And as Dan said, if you have any questions that you find after the webinar is done today, please feel free to send me an email off of the LTAP website, or you can contact Dan directly. So thank you, Dan.
Thank you much, Wendy.
Thank you to the U of M.